Good morning, good afternoon, and good evening to all the participants of the third International Conference on Disaster Resilient Infrastructure being organized by Coalition for Disaster Resilient Infrastructure. Today is the second day of the conference, and for those of you who were not able to join us yesterday, let me briefly recapitulate the first day's happenings. We started the sessions by the inaugural session, where we heard the Honorable Prime Ministers of India, United Kingdom, Fiji, and Italy about their vision of resilience vis-a-vis climate and disasters and the urgent actions to be taken to achieve that. As the Prime Minister of India, Mr. Narendra Modi said, no one is safe till everyone is safe. And in our quest for resilience, we cannot leave any place, economy, or ecosystem behind. The inaugural session was followed by the session on health infrastructure, which was really very topical in view of the COVID-19 pandemic. And the experts and policymakers discussed not only impact of COVID-19 on the health infrastructure systems, but also on other infrastructure systems. One of the quotes from the session was that, which was made by Ms. Lauren Brown, that putting factual information in public domain and communicating it is of vital importance so that spread of misinformation can be prevented. The third session of the day was about risk modeling and resilience. Experts from leading institutions who are working on risk and resilience studies discussed the resilience aspects and studies and need of such studies. What Professor Jim Hall said in the session, that the data analytics and such technical studies can help us in designing the interventions in such a way that they are as per the need of the societies and economies in all parts of the world. The last session of the day was when we heard high-level functionaries like Dr. P.K. Mishra, the Principal Secretary to the Prime Minister, Mr. Akim Steiner, the Administrator of UNDP, and Ms. Mami Mizotori, the UNDRR Chief. Dr. P.K. Mishra emphasized the need to leapfrog countries to integrated infrastructure planning so that they can use the advanced data analytics and tools which are available now. Mr. Akim Steiner mentioned that only about 16% of global stimulus packages which have been announced by countries are addressed to green recovery and green development. And Ms. Mami Mizotori made a strong statement that we were not even on the road or on the path to climate resilience even before the COVID-19 pandemic. So that was yesterday's conference, a day of speeches with vision and scintillating discussions. Today we started the day with a session on one of the most important geographies of the world, that is the small island developing states in the Pacific region. We had the SIDS representatives as well as the Secretary General of Pacific Island Forum and other representatives of institutions who are working in the area. And some of the key quotes which I can say now were that the Pacific has proven its resilience in spite of the vulnerabilities. SIDS are in the constant state of recovery because of the frequent disasters, and that the Pacific countries should not be called SIDS, but BOSS, the big ocean states, because they are the custodian of the largest ocean of the world. So now, with all that background, let us move to the next session, which is an exciting session about innovations and emerging technologies. As all of us know that whenever we are in the state of adversity, we turn to innovations and technology. And the last 1 year and more has proven that. We are holding this conference only because of the advances in digital technology. Our homes have turned into our offices, and we are able to get in touch with our colleagues across the world using digital technology. The unprecedented pace with which vaccines have been developed again show the strength of technology in biological field. So to discuss these and many more important issues, now let me turn to Dr. Arunabha Ghosh, who will moderate the next discussion. Dr. Arunabha, CEO, Chief Executive Officer of Council for Energy, Environment and Water. He is an author, a policy researcher, a columnist, and as co-founder of, as a founder CEO of CEEW, he has taken and led this institution to one of the leading institutions and research institutions of Asia. He is also the co-founder of Clean Energy Access Network, which is in short called CLEAN, and the co-chair of the World Economic Forum's Global Future Council for Clean Air. So before handing over the session to Dr. Ghosh, let us see a short video on innovations and emerging technologies.
Disasters disrupt all aspects of our lives, our health, the houses we live in, the cities we inhabit. Disasters are everywhere. And they are becoming more frequent, deadly, and unpredictable. So, how can we become resilient? We innovate. In simple words, innovation is the creation of something that improves the way we live our lives. Creativity and innovation can help us to develop solutions for big and complex problems. Recently, innovation, coupled with high-end technologies, have helped us to face disasters efficiently. After the Fukushima earthquake in Japan, underwater robots helped in finding the missing nuclear fuel in the reactor core. During COVID-19, strong telecommunication infrastructure allowed people to work from home and helped in the tracing of COVID patients. New technologies of data collection and computing power can provide more reliable information to support building of disaster-resilient infrastructure. 3D printing, virtual reality, and biomimicry are the next big things, with the potential to revolutionize design and the building of infrastructure. The enormous potential of innovation and technologies is being recognized globally. Governments and institutions have also launched innovation competitions and incubation centers. As we imagine a disaster-resilient world, we cannot imagine it without innovation and new technologies. So, let's come together. Let's imagine. Let's innovate. Let's make the world a better and a more resilient place.
Good day to all of you from wherever in the world you are watching us. We've already entered the second day of the International Conference for Disaster Resilient Infrastructure, and I'm delighted to welcome you to this very important session on what innovation can do to help us make our infrastructure more resilient. I'm Arunabha Ghosh. I'm the CEO of the Council on Energy, Environment and Water, here based in India, and we work across many emerging economies across the world. What is infrastructure and what is innovation? Infrastructure is not just engineering and concrete, although that is very important. Infrastructure is not just about the digital backbone that is often needed, although that is important. Infrastructure is also about governance capacity, and infrastructure is also about the resilience of communities. When we bring these four legs of the stool together, the technology, the finance and business models, the governance capacity, as well as the resilience of communities, then we can be looking at innovations across all of these domains to make sure that whatever we are working on lasts not just for now, but for many decades into the future and keeps delivering value for the purposes that this infrastructure has been built. It is in that vein that innovation also has to be oriented towards the way in which we use infrastructure, not just the way in which we build infrastructure. How does the physical asset, the natural environment, and the human capital interact, and where are opportunities for innovation to make each of those elements resilient. Where are opportunities for technological innovation, and where are opportunities for innovations in financing mechanisms? Are the best technologies being deployed, or are they being sidelined because they're found to be too expensive or too risky to be invested in? If we begin to think about infrastructure in this holistic manner, if we begin to think about innovation in this design-oriented manner, then perhaps we'll manage to, pun intended, create a bridge between the resilience of infrastructure on one side and the innovations that can drive it on the other. Today, you're going to hear from a stellar set of panelists and keynote speakers through the afternoon. And it gives me great pleasure to introduce all of them before I turn to our first keynote speaker to speak. Dr. Anil Kakotka, the former chairman of the Atomic Energy Commission of India, former secretary to the Government of India for the Department of Atomic Energy, could be considered the doyen of the nuclear energy establishment in the country. He joined the Bhabha Atomic Research Center way back in 1964, and since then was instrumental in all the atomic energy innovations that India developed through the decades. He currently devotes his time on various issues relating to energy, to education, and to social development. He's been propagating, in fact, an idea called Silage, how a knowledge-based ecosystem can bridge village and city technology gaps to make the economy far more resilient and vibrant. And it also gives me great pleasure to say that Dr. Karkoutkar serves on the board of my institution. Dr. Karkoutkar's keynote will be followed by 3 outstanding technical presentations on different innovations from across the world. You'll hear from Ms. Jacqueline Hood, who is the Highways Market Director for Amy Consulting from the United Kingdom. Ms. Hood has a background in geography and has been leading the strategic consulting team at Amy Consulting and has worked extensively with various institutions such as the UK Highways Authority, Transport Scotland, as well as local authorities. She works with these institutions to identify and deliver the data-driven solutions and technologies with the goal of driving better decision-making in real time, but also transforming infrastructure and driving value in that investment. Amy will be followed by Mr. Amir Dinur, who is the CEO of Seismic AI, a company based out of Israel, and the winner of the World Bank Tech Emerge competition. Mr. Dinur has been leading high-tech ventures in Israel for the past 15 years. He joined Seismic AI as co-founder and has revolutionized earthquake early warning systems, making it quicker, more accurate, more reliable, and more accessible, effectively democratizing earthquake warnings. He now is leading his team with the application of physics-based array seismology to enhance tsunami early warning systems. And you'll hear a lot about this in his presentation. We will then hear from Ms. Olga Plumakers, who's the director for Nellen & Schumans, a company based out of Netherlands, and again a winner of the World Bank Tech Emerge competition. Ms. Plumakers started her career as a hydraulic consultant at Nellen & Schumans after she completed her master's at Delft University in the Netherlands. She specialized in the field of urban water management and climate adaptation, and then became the head of the Department for Urban Water Management. She's been involved in the development of 3DI, a state-of-the-art hydrodynamic simulation software for fluvial and coastal floods. And in 2019, she was promoted to the management team of her company as director of the business line for consultancy services. And from her, you will hear about how innovation solutions can be looked at in terms of predicting and responding to floods in different domains. After these 3 technical presentations, we will get a little bit of a sense check on how do we shift from that innovation, the technological innovation story, to the systems dynamics that we also want to ensure that we have an eye on. And for that, we have Professor Bani Banerjee, the director for Stanford Change Labs, and who's known for his pioneering work on systems innovation. He's been working in this area of innovation and design for 30 years and is well known for his pioneering work in design thinking and more recently in advanced systems-based innovation methodologies and systems leadership-based systems leadership models for large-scale transformations. From Professor Banerjee, you will hear why it is important to not just look at the technological side, but to understand those interactions within the wider ecosystem of governance, of community, and of other systems with which our infrastructure interacts, to make sure that the resilience is not just a one-off, but is embedded across these systems. Of course, it's not easy to do any of that, but that's why we have to keep our eye on those important matters. And to close off the session, we will then hear from Brazil. Dr. Osvaldo Luiz Leal de Moraes, Director of the National Center for Monitoring and Early Warning of Natural Disasters, the CEMADEN, in the Ministry of Science and Technology and Innovation in Brazil. He is a graduate and doctorate in physics from the Federal University of Rio Grande do Sul. His field of expertise is in atmospheric sciences. Currently, he's acting as the director of CEMADEN. He's also the chair of the Standing Committee for Disaster Risk Reduction from the World Meteorological Organization. And previously, he's been director of Research and Development Policy and Programs in the Ministry of Science, Technology, and Innovation in Brazil. So, as you can see, we have a panel comprising people from across domain areas, from across geographies, and from across elements of that innovation and infrastructure bridge that I was referring to. But first, we want to hear from all of you. If you look at your screens, there's a tab for a poll, and we want you to answer the question that I'm going to pose to you. In your opinion, which types of innovation can be most effective in building disaster-resilient infrastructure? The options you will see are technological innovations, such as high-tech products and process innovations, or system innovation, focusing on policies, on governance models and administrative capacity, or 3, social innovation, wider inclusion of community behavior, and of course the local culture, and 4, financial innovation, to enable the investments in resilient infrastructure. So please take a couple of minutes to go to that tab and give your results, give your opinions, and we'll convey those results back to you in a few minutes from now. But now it gives me great pleasure, and in fact, it's my privilege to welcome our keynote speaker, Dr. Anil Kakotka, to provide his systems-level view on infrastructure, on resilience, and ensuring that our urban, our rural, and everything in between is built to last. Dr. Karkoutkar.
Thank you, Dr. Ghosh. Am I audible?
Yes, Dr. Karkoutkar, we can hear you.
Okay, thank you. So let me first of all express my thanks to the organizers of the conference on disaster resilient infrastructure, and in particular, this particular session on innovation and emerging technologies for uncertain future. I want to begin with an anecdote. I happened to be traveling in a train on holidays when tsunami struck India on December 26, 2004. And the area that was affected also included Kalpakam, where our nuclear research center, there are reactors, power plants, they are located. And I got the news that there is kind of, the tsunami has hit, and particularly in the residential colony, which is several kilometers away from nuclear site, there have been many, many casualties. I reached the Kalpakam site immediately thereafter. There was obviously a very bad scene, a scene of deluge, as it were. And there was on one side the important and urgent thing to take care of the serious damage to life that has taken place in the residential colony. And also there was a lot of anxiety, particularly among people, about what is happening or what has happened to the nuclear facilities. And I had actually worked on to look at, safety and disaster syndrome earlier. And that was my testing ground to look at this. And I found that one big factor was irrational fear. And that's driving people at that time in a scenario like this. And their second is a disaster syndrome, and two are not the same. But, and both are actually different than what one may call a rational view about safety. I'll come to this point a little later, but it's important that when we talk about disasters, we have all the three elements in view. When we talk about infrastructure, again, as was mentioned earlier, we have to deal with all kinds of infrastructure. The critical infrastructure, which are of course important, and they have to be engineered to take care of extreme events. Extreme events triggered externally, or extreme events which could be triggered internally within the system. And we must have the design of the infrastructure done in a manner that in the rarest of the rare extreme event, the infrastructure will stand. Then there is general, the habitat, the cities, the townships, and so on. Now, I think it's equally necessary that there is a reasonable level of disaster resilient and or disaster resistance and climate resilience in the dwellings which we have for the people. And I think this is an area where we need a lot to do. I was involved in shaping the technology vision 2035 when I was in TIFAC. And there, one of the statements which has been made in those documents is to ensure that all dwellings are disaster resistant and climate resilient. And there should be a possibility of medical evaluation promptly, in any case no later than 1 hour. And there should be a helipad in every panchayat, the local self-government. But the view of infrastructure is not limited to that. It actually goes beyond. It actually talks about the society and the infrastructure which is utilized by the society. And the recent example, when there was massive distress, reverse migration from cities to villages following the lockdown in the recent pandemic, has shown serious weaknesses and livelihood instability in our urban infrastructure. So that's another important element about infrastructure. Now, when we design infrastructure for extreme events, we also need to recognize that the definition of extreme event, or the design basis event as it is called, it's not a fixed entity in time. even for natural events like cyclones, floods, and things like that, I think there is an interference between human activities and what happens in nature. Climate change is a classic example. So even if I had designed an infrastructure for so many thousand years return period, you would find that the intensity to which the infrastructure is likely to be subjected during its lifetime becomes somewhat larger than what it was designed for. And there is a need to carry out review and retrofit. And there must be some scope to accommodate this additional need in the design, or at least there should be a design for accommodating such retrofits. And this has been felt the need time and again, and I'm sure some of our eminent experts would address this. The next aspect is early warning system, and there are technologies which have evolved quite a bit, including earthquake, and I'm glad that we are going to have a presentation on that. But it's important that you have very dependable, credible, and robust early warning system, which gives us as much of lead time as is possible. And finally, after having incorporated all these elements, we must have area by area or facility by facility emergency response plan, which includes preparedness, response, and recovery in order to lessen the impact of disaster. So the disaster management framework has to cover all this at multiple levels, because it's a question of management, organization of resources, and responsibilities for dealing with all humanitarian aspects of emergencies, so which includes evacuation, sheltering, relief supplies, transportation, communication, which must be both secure and reliable, a control center from which you can guide activities, and which must have the required level of smartness and intelligence, and a very dependable and robust decision support system. And you would immediately notice that all these areas are matters of really high technology, which has been evolving continuously. And so there is a lot of scope for innovation. Now, having made that broad introduction for aspects related to disaster and the resilience that we need to build in, I want to make three specific points. First is to recognize that there is a continuous dynamics at work, whether we're talking about natural phenomena or whether you're talking about man-made phenomena. And as I said earlier, the two are interrelated. Now, to me, in the context of disaster management, sustainability actually amounts to minimizing interference of man-made activities in natural processes. You design an infrastructure and you find that the assumptions made as to maximum flood or maximum storm that you would see, they become no longer valid in a period of 10 years or 20 years. And one needs to carry out review, is actually a result of man-made activities on the natural process, that interference. And secondly, it's important that we should be able to quantitatively understand these interrelationships and their impact. And this is an evolving area. I think we are, in my view, we are still at very early stages of this knowledge domain. But I think there is great need to be quantitatively correct on this understanding. Now, adaptability, ability to resilience against disaster. this issue keeps on coming because the instability in events which cause disasters, natural or even man-made or even natural, is because the rate at which things are changing. And with call it impact of man-made activities or impact of advent of technologies, I think the rate of change has become much faster than it was earlier. And so I think we are creating a lot of gradients in both man-made processes as well as natural processes. And in complex systems, many of these gradients do lead to instabilities. And then that becomes an extreme phenomenon. And so while we must improve our understanding, quantitative understanding of these phenomena, I think it's important to realize when we are all talking about sustainability, we must realize that the way we conduct ourselves, the way human beings are, what is our concept of development, and we factor that in a manner to make sure that we don't contribute to heavy instabilities getting into the system. So that is the first point that I wish to drive. The second point that I wish to drive is related to understand the disaster syndrome, which I mentioned earlier. And this is actually linked to human mind. And nobody wants anything that might cause a disaster or that has a semblance of a disaster in his or her backyard. There is that NIMBY syndrome operating. So we need to treat infrastructure and neighborhood together and have a robust response plan where there is a shared ownership between the facility or the infrastructure and the society at large. And the two should act in a manner that we keep these extreme events under check. Now, I said that the infrastructure could have, issues can arise because of infrastructure on the neighborhood or the vice versa. And so one important element in ensuring that infrastructure is robust is to depend on what are known as passive systems, because the chance of active systems failing is somewhat higher compared to passive systems failing. And so that is one element. And even very large complex systems, one can configure them with maximum passive safety and you will get more robust performance. But it's not as if passive systems don't fail. And that has something to do with the ethics in human society, which I suspect are getting degraded. So, these passive structures also tend to age. Passive structures also tend to fail because of various flaws or defects that get left in. And so we need to, in fact, think of an innovative society that is creative and sensitive, both with respect to technological innovation, but also with respect to where infrastructure should be configured vis-a-vis society. I want to end with the last point, and that is with respect to cooperation or potential cooperation among the CDRI partners. I think it's important that there is active knowledge sharing, experience sharing, and resource sharing, and there could be many innovative approaches right within that framework. And also, we must deal with transboundary aspects in case of disasters. And that also has multiple dimensions, early warning, relief, rehabilitation, and so on. So friends, it's a large domain, a very important domain, an evolving domain, and I'm sure the experts experts who are a part of this panel would enlighten us in terms of how the innovation will play an important role in spite of the fact that there is so much of uncertainty in the context of disaster or disaster resilience. Thank you very much.
Thank you, Dr. Karkoutkar, for outlining the step-by-step framework that we need to build resilient infrastructure, but also those critical insights that you brought out in terms of recognizing those continuous dynamics, in creating a society, in your words, which is both creative and sensitive. And hopefully, if we have societies like that across nations, then we can also have the cooperation that you're seeking. I'm going to quickly give the poll results. We have in first place with 40.6% of the votes coming in for system innovation. And in second place for 29%, with 29% of the votes for social innovation. And with 24.6% of the votes, technological innovation. Only 5.8% of the votes have gone for financial innovation. I guess we assume that if we can get the systems and the social framework right and the technology to embed, the money will flow. But let me now turn to the technologists and see whether they would agree. And without any further ado, let me invite Jacqueline Hood of Amy Consulting to make her technical presentation. We are running a little behind time, so I would request all the technical presentations to stick to their time limit of 7 minutes. Thank you. Jacqueline.
Hi, everybody. My name is Jacqueline Hood. I'm a market director at Amy Consulting. What I really want to focus on, if we could go to the next slide, please. What I'm going to focus on in the next 5 minutes or so is using data, innovation, and technology to actually drive decision-making around our infrastructure. So using those aspects to make better decisions around operations of things like bridges, but also using that data and technology to drive better understanding of where our risk areas are in terms of those assets and infrastructure. And this has never been more important with the ongoing climate emergency. We're seeing more and more severe weather events, more variability in our weather, and we need to understand how our infrastructure is behaving during these events, but also to then manage those the infrastructure after those events as well, so we don't get any surprise failures as we saw in Italy in 2018. Oh, if we could go back one slide. Thank you. Where Amy Consulting has done a lot of work in this space around using data and technology to drive these better decisions is up in the Forth Road Bridge up in Scotland. So this is an area, or the bridge I should say, is a massively important piece of infrastructure for that part of the world, connects Edinburgh to the north of Scotland, and has millions of commuters each year that use that bridge to get to work. And unfortunately, in 2015, there was a truss end failure at one end of the bridge, and this was caught through a routine inspection, was fairly unexpected, but a serious failure that caused the bridge to close for several months. And it's through, repeated weather events that these kinds of failures happen. Next slide, please. Our solution was, when we had a stock take after the event, we realised that we needed better data and better information to manage the bridge in the future and ultimately prevent those kinds of failures from happening in the first place. So we stood up an infrastructure monitoring and analytics platform, cloud-based, that actually ingests sensor data from sensors across the whole span of the bridge at strategic locations, feeds this information back in real time so that we can fully understand how a bridge is behaving at any given point. So for the Forth Road Bridge, we were able to, if we go back just one, thank you. Thank you. For the Forth Road Bridge with those sensors, actually we were able to visualize that information for operators live in the control room. So they've got a picture there and then of how the bridge is behaving, as part of business as usual, but also as part of severe weather events when they do come round. And you've got that intelligent alarm system as well in there that can send immediate text messages, immediate emails to the guys in the control room to ultimately, if a threshold is met for a certain risk factor, so for example, wind or ice accretion on the bridge, they can close that bridge immediately to passengers using it, to customers using it. Next slide. So this is one of these sensors in action. So this is actually showing a storm that happened that led to about 200 millimeters of longitudinal shift in a bearing, which doesn't sound like a lot, but when you scale that up over the whole structure, that could be quite impactful and could lead to a larger risk of failure. And actually, this is information that the control room for the bridge has live. So they can see through a weather event what is happening on the bridge, how is it behaving. That not only leads to better operation there and then, making sure that we're running a bridge that is safe, but ultimately means we can inform our maintenance schedules as well. So we can make better decisions about when and where we target our inspections and maintenance to make sure no failure is going to surprise us. Here we have a bit of an example of one of these urgent alerts. So here we had a threshold met on a wind gust that then led to a recommendation of closure of the bridge to pedestrians and cyclists, and ultimately making sure the bridge is safe for them to use. But we also have a series of these other alerts for things like ice, to prevent ice bombs on the carriageway, which are genuinely a threat to life sometimes. Next slide, please. We also, I mentioned, we have that machine learning element in there, that intelligent analytics. And this is the really, really interesting bit for me in the solution that we've helped build. So actually, we use that historic data that we've got, the raft of data we've had since 2015, to fundamentally predict and look forward to how a bridge could react and could behave in the future. So we know ahead of time, as we have weather events coming in, how the bridge might react to that. And ultimately, this means that we can target inspection and maintenance before an event to check that things like bearings and truss ends are all in good shape. But also then we can check afterwards as well, because we know how that bridge is gonna react to the event. So actually, we're using that historic data to better inform our response and our decision making around those future events. Next slide. To kind of conclude on all of this, obviously, as we see climate change really take hold, we're going to see more variability, more changeability in our weather, which generally is going to put aspects like those truss ends, bearings at risk continually. And actually, without data and technology such as we've used on the Forth Road Bridge, we aren't able to make the best decisions we need to make to ensure safe operation day to day, but also that making sure that we make the right decisions around maintenance of the bridge to prevent incidents like we have had in Italy. And using these new technologies around machine learning, unlocking that data is really critical to this, to mean we're not making anecdotal decision making, we're actually using and making decisions based on data. And the final point I'll make as well is that that data doesn't have to be real time to be valuable. So there can be quite an obsession about, I must have real-time data. Actually, having that bulk of historic data is part of underpinning how you respond in the future. So there's value on all counts on that. And thank you very much. That's it for me. I think we have Mr. Amir Dinur next.
Yes, thank you so much, Jackie, for outlining through your example exactly what Dr. Karkoutkar was saying, that quantitative understanding of those continuous dynamics. And your last words is, I think, the difference between information and knowledge. The real-time information, when built up over time, delivers that knowledge base for us to make better predictions. Amir, over to you to tell us how real-time seismic information can make our infrastructure more resilient.
Sure. Thank you so much. I don't see my presentation, so here I see it. Yeah.
Yes. It's up
Great to see you all. My name is Amir Dinur. I'm the CEO and one of the founders of Seismic AI. It's a startup company together with Tel Aviv University and other universities around the world. If you can kindly switch to the next slide. Yeah, so one of the problems we see in the world that almost, if we exclude Japan and some part of California, rest of the world is not covered with seismic early warning system in real time, in a regional orientation. And we can see that even in those countries that you have partial solution, they won't detect earthquake out of their network. So if something is coming from the ocean level or something is coming from other country, for example, in India, if something will start 500 kilometers away from the Himalaya, in China or in Pakistan, you won't get a real-time solution alerting the people. When I say real-time, it's less than a second. So we, if you can kindly switch to the next slide, what we managed to do after a research of more than 10 years, can kindly switch to the next slide? What we managed to do in research, and you can find the publication of our solution in several in the best places in the academic world. We managed to develop a system that, first of all, can run immediately. So we don't need to have any empirical data to our solution. We can install it in everywhere in the world in a few days, and it can be operational in a few weeks. So if we compare it to the Japanese system or to the American system, it took them around 50 to 20 years just to calibrate the system. With our technology, which is a combination of a lot of artificial intelligence and a lot of new ways to detect earthquake using array technology, I don't have time to share it with you, but if you want, you're more than welcome to talk with me. We can be operational in a few weeks. The second thing is, instead of having very dense networks with billions of dollars of investment, you can do it in a few millions of dollars, and you can cover huge areas in few stations, and you don't need to put every station every 5 kilometers. So let's talk a little bit about the impact. So if we will alert even people 5 to 10 seconds before something happens, we can save their life, they can take cover. Same go to nuclear plant, power plants, and transportation. If we will alert on time, even few seconds before the earthquake is coming, we can actually reduce dramatically the damage. We can save a lot of lives. We have a lot of research publication about it and case studies all around the world showing how we can really save lives and reduce dramatically the damage. If you can kindly switch to the next slide. Okay, even the next slide, because we don't have a lot of time. The last thing is super important, and we learned about it from the Japanese and also from our conversation with the federal in the US, business continuity, which means after an earthquake, I don't want to be in a situation that I don't have hospital to go or I don't have water to drink because everything was destroyed. So we are actually working today with the infrastructure in order to minimize the damage once in the way that we can actually have automatic shutdowns for relevant infrastructure and machines inside the infrastructure. So before the earthquake is going to hit, we can reduce the pressure of the gas. We can stop engines. We can stop pumps. We can open valves automatically, even half minute to 1 minute before something has happened. And this is dramatically can change the situation. Now, let's move to the next slide, please. I just want to show you some case studies. We are working all around the world. We have networks in India, in the Himalaya. We have networks in Turkey. By the way, in Turkey, we managed to detect earthquake 12 hours after we put our system, 100 kilometers in the sea level, which is something that even the Japanese don't know how to do. So in the Himalaya, for example, we have a small network in Uttarakhand, and we manage with this system to detect earthquake also coming from China, 500 kilometers away, from Pakistan, 800 kilometers away. So we can be actually the eyes, for example, of India out of the political borders. So if something's starting far away, we can actually alert on time and get a lot of time before the earthquake is coming and alert people. So actually, I'm done. I will be happy if you have any question, if you want to contact me, and I will let Dr. Olga now to have her session. So thank you so much.
Dr. Makers, Olga, over to you, and let's please restrict the presentation to 5 minutes. So we'll have some time for questions.
Yes. Hi, my name is Olga Pleumakers. I'm from the Netherlands, where half of our country is beneath sea level. So you can imagine we have some experience with keeping our feet dry. Next, please. I started my career 10 years ago at Nederland Schuurmans, which is a water management consultancy and IT company. And our mission is contributing to a healthy, safe, and resilient environment. And we achieve this by making the best information available to the decision making using our IT and consultancy services. My personal goal is to translate the in-house IT solutions into an applied service for customers in the water and climate domain. And we do that in the Netherlands a lot, but also abroad. Can you go back, please? We are developing two main IT services. We call them Lizard and 3DI. And where Lizard is an online geodata warehouse and analytic platform, and 3DI is a state-of-the-art hydrodynamic simulation software for floods. And the flood forecast service, where this pitch is about, is based on the combination of both Lizard and 3DI. And you can go next, yeah. For many years, our daily business is flood modeling. And over the years, the input data become more detailed and more accurate. And beside that, we also improved the simulation software, where we made it both more accurate and much, much more faster. And since a few years, please go back, we use flood models to create a climate atlas for regions and cities. And it's an online atlas where we show the impact of the climate change, but not only by showing the water depth and flow velocities, but also translate them to vulnerable objects like the impassable roads or damage to buildings and hospitals, but also failure of the energy net. And for this translation, we use an asset database and advanced algorithms. As you can imagine, this climate atlas gives you a lot of information. This is also very static. And the maps are calculated in advance and show potential risk. And the next step was to use our hydrodynamic model and the data warehouse to set up a dynamic forecasting service. We made this, please go back one. We made an automatic data import to the data warehouse, for example, rainfall radar data and weather forecast information and water level measurements. And at the same time, there's an accurate flood model available to the specific catchment or city. And this model is automatically fed with the measurements of rainfall forecast of the area. And we use both, use it both as the boundary condition for the model, but also for the external forcing of the model. And with that, we will run the model automatically, and the flood results will also be automatically stored in this data warehouse. And from there, predefined impact analyses are executed, which are based on predefined threshold values. And an alert will be sent out at the moment these threshold values are exceeded. Next, please. And because the service is cloud-based, all steps can be run and followed through mobile phone, and the results of the flood model and the executed analytics are visualized in these kinds of dashboards, and they can also visualize on your mobile phone, as you can see in the next slide. And messages can be sent out by social media to inform civilians, but also by text messages to the security services. And in the flood forecasting service, we do not only provide information about water depths and flow velocities, but also about the impact of that. For example, if the roads are passable or not, if buildings were flooded and where, if there are risk of failure of the electricity network, and so on. So with this kind of information, it is possible to react fast and location specific to the predicted floods. I want to finish this pitch with 3 important questions about the flood forecasting service that we hear more often. Next, please. First, is the model and the service accurate? For the model and also for the service applied, garbage in is garbage out. So the accuracy of the service itself is very high, but you need accurate data on rainfall forecast, measurements, and also geo information to build an accurate flood model. But the calculation core itself is very, very accurate. The second question, is the service real time? The flood forecast is as quick and as good as the weather forecast, of course. Simulations and analytics are very fast, and at the moment the weather forecast is available, the flood forecast is calculated in minutes to hours depending on the area you calculate. And last question, what are the things that you need to prepare in advance to implement this kind of service? First, you need to build a calibrated hydrodynamic model. And because more and more data is available, this is not longer a challenge for many countries. And to execute the analytics, you also need a measuring network and KPIs and a list of decision criteria to automatically send out notifications. So far, my short presentation about our innovation flood forecast service. I hope it gave you an idea of where we're working on and how it can help cities or countries to respond on floods in the future.
Thank you so much, Olga, for sticking to 5 minutes and for ending the presentation with those very clear questions. I'm going to change the format a little bit, and I'm going to first bring in Professor Banerjee to give his speech, and then I'm going to come back with a question each for each one of you before we go to Dr. Moraes. Professor Banerjee, you've heard of each of these elements of real-time information, but then providing that information in a way that it is usable by administrative systems, etc. But where you come at this from, how do you see these innovations, the technological innovations, fitting in the broader resilience framework? Over to you.
Thank you for having me, Anurabha, and it's a pleasure to be here. Anurabha mentioned that I work in the area of systems, and where with challenges that have the attributes of extreme scale, complexity, urgency, often very, very critical to function, and also, generally speaking, with great threats to resilience. And with the moment you take a systems point of view, the boundary conditions, the first thing you do is increase the boundary conditions, and then the hard infrastructure and the technological layers become enmeshed with many other layers. So the other layer, the other components that you were talking about, the four legs, are many parts of the system, but this moment you do that, you go from the complicated regime to the complex regime, where tight deterministic relationships get coupled with much more looser and dynamic relationships, where feedback loops and choke points and so on become really, really important to understand. And also the capacity to understand them becomes incredibly important. So when you have that system and then you look at technology, you realize that while particularly now in the midst of the fourth industrial revolution with frame-changing technology and the kind of technology we are talking about, which can give us entirely new categories of thinking, decision-making, response times, etc., our enemy is the degree to which we are technocentric in the way we think about using the technology. Because when we have these kind of technologies available, then the magic often becomes how we integrate those technologies with the non-technology layers, so to speak, and the other way, the heuristics and the entire infrastructural, the institutional capacities or the social capacities that are enmeshed with those. And how do you design for that? And also we are talking about resilience risks and an era where we are entering I would say an epoch with greater risks of a multitude of tsunamis coming at us with greater frequency, with greater intensity. And meanwhile, a whole lot of the infrastructure that we've built, including our institutional capacities, are relatively brittle in its face. And so when such events happen, given the heterogeneity of the system and the unknown nature, failure is inevitable. And so the question is that we have very many different time constants from the way we design systems and the way we design institutional capacities to the extremely short periods of time that we have to respond to them, but also not just respond to restoring the function of the infrastructure, but the fact that the infrastructure is a bedrock of a whole stack of the societal functions that rely on the infrastructure, and those, when they have broken down, what does it take to restore those? And how are you going to leverage the more distributed functions such as the ones that Dr. Karkoutkar mentioned, and that is a really important point. So once you take a systems approach, the question I guess, that is posed in front of us is that we have to transition to much more fault tolerant and resilient systems. But as we do that, we absolutely cannot sidestep the fact that the forces that have caused this issue to be an important issue. The shape of the infrastructure and a definition of progress, and the architectures with which we've created it, the centralized ways in which we've created the relatively rigid institutional capacities and the brittle nature of the architectures of the infrastructure itself, also has been extremely culpable in contributing to the magnitude and the nature of the forces that attack us. So to Dr. Kakotkar's point, we absolutely need to not have those be externalized, but internalized into the way we do it. Mm-hmm. But infrastructure is extremely large and expensive, etc. And what we realize is that when you look at systems, it is extremely prudent to look at systems and ask where you might intervene with the greatest amount of effect. And so we have a methodology that we call systems acupuncture, where there's a whole new philosophy of how you look at building that kind of intellectual ability, the agility, the institutional agility, and also the directionality of what is it that we are designing. Because currently we are not only designing transitions to resilient systems, but also the next generation systems. And at what point are we going to reshape the entire architecture? And the moment we look at it in this way, we realize that the way we even use words have tremendous import on how we think about it. So if we think of infrastructure, we immediately think of dams. But if we think of, let's say, water security, access and equity, and everything else serving that, then a dam becomes a piece of it. And so reconceptualizing not only what we are doing, but building completely new capacities that build agility and a much more systems perspective, because the challenges are systemic and are in the complex realm. And I'm going to pause for that.
Thank you so much, Professor Banerjee, for illustrating for us this notion of what a systems acupuncture approach could look like. I'm going to rush back to the panelists with literally a 1-minute question here, because we have to close within the next 9 minutes, and we have Dr. Moraes also after this. I want to go first to Jacqueline. You just heard from Professor Banerjee about the brittleness of infrastructure. So when you look at the way the bridge is functioning, who should be responsible for handling that information to make sure that then the response and that learning, that long-term knowledge management that you were referring to, is embedded through the system and not just episodic?
Yeah, so it's a really interesting area that actually, because ultimately the asset, the bridge, if I use FRB as a bit of an example, Transport Scotland are fundamentally the asset owners. They are responsible for that bridge. They bring in the likes of Amy Consulting, among a series of other partners, to actually come in and operate, manage and maintain. It's almost pushing the risk. It spreads the risk a little bit, so that the likes of Amy are kind of managing that risk in terms of that bridge operations and function, and if there is a failure. And it's a very interesting point, because actually suppliers will have a contract for a set period. It might be 5 years, it might be 10 years, but actually after that, that supplier might well move on. And all of the data and intelligence that they had, there is a genuine risk that it doesn't move on to the next supplier who takes on that risk for the ultimate asset owner, which I think it's a challenge. I think the way that you overcome it is making sure that, when you're building these kind of databases, these systems, technologies, actually you're not building it so it's so specific to your own supplier use case. So making sure that the work that we've done is able to be transferred over to the next supplier, because ultimately if you can't do that, that supplier is almost starting back at square one, and you lose all of that intelligence and progress that you have just made in particular. So I think it's it's potentially flawed, but there are ways and means to progress it.
Okay, thanks, Jackie. Quickly, Amer, over to you. This real-time information on the earthquakes, how do we democratize this system even more? So what you've done is you've made sure that you can quickly deploy this, but how do we democratize that information so that there are more responders ready to act?
So thank you for the question. So all the data in real time is actually available in several levels, and we believe that we will never, as a policy, we will never stop the information from the population. So it is a commercial solution, but in every country that we have the network, we won't charge the population for that, and we will we're already enabling a very, very easy internet API, so you can connect us with us in any platform. It can be your mobile, it can be website, it can be even your alert system. Everything is connected via the cloud. We are cooperating with Microsoft, and soon also with Amazon. So everything is shared and open. We do have commercial aspects for cities, for infrastructure, but in general, for the publication, it's totally open.
Okay, thank you. And Olga, to you, Dr. Karkoutkar talked about cooperation across countries. So how do we use your flood warning system in transboundary situations?
Yes, for flood forecast service, you need a simulation model of the entire catchment, and the border doesn't determine the extent of the model. So the catchment does that. And from the technical point of view, it's no problem that the catchment lies in two different countries. And most of the time, the input data, like the elevation map, satellite images, are also not restricted by national borders. So for an example, besides using the Dutch rainfall radar, we also integrate the rainfall radar of Germany and Belgium, which are neighbor countries. And the flood forecast service itself is most of the time restricted to a specific governmental authority with specific requirements, but the flood model is not.
Okay. We'll jump straight to Dr. Moraes. Sir, you have 5 minutes, and then we'll have to close immediately after. I'll try to bring in a question for Professor Banerjee. So over to you, sir. Dr. Moraes.
Do you hear me?
Yes.
Well, thanks a lot. Well, many thanks, Mr. Chair. Good afternoon, good evening, and good morning for all attending this section. And many thanks for the invitation to be present in this section. Well, usually innovation is related with development of technology. However, innovation can be intangible, as opposed of technology, which is tangible. You can even apply the innovation process to your everyday life. Technology can be used to implement innovation, but technology itself doesn't produce innovation. I will briefly address how innovation can be useful for resilience, not only for resilience of infrastructure, but mainly for people using infrastructure existing in risky areas for disasters. Let me put a different overview on how to use disruptive innovation in the field of disaster resilient infrastructure. The start point is to look what means disruptive innovation. in business theory, disruptive innovation is innovation that creates a new market and value network, and eventually disrupt an existing market and value network, displaced establishing market-leading firms, products, and alliances. However, disruptive innovation can also be considered disrupt a complex system. Through identifying and analyzing systems for possible points of intervention, you can then design changes focused on disruptive interventions. It's important, in this point, I will exemplify here very quickly how the Brazilian National Monitoring and Alert Center for Disaster uses a methodological innovation to issue alerts that
So we'll have
cause
to wrap in
deaths.
a minute and a half. Yeah.
Okay, thank you. This innovative but very simple process go behind the using an alert for extreme events. Well, I will show to, I will briefly to explain. For instance, in Brazil, there are more than 50,000 risky areas for mass movement where lives more than 10 million people. How to use an innovative procedure to make the schools that exist in these areas. For instance, in Brazil, there are more 2,000 schools existing in risky areas for disasters. Then you developing a system to create not only the resilience of this structure, but the resilience of the students and the teachers that stay in these areas. You use a methodology and the more important contribution for a resilient society is a resilience of the people and not only the resilience of the structure. That in a simple way, what I would like to exchange with you. Thanks a lot.
Thank you so much. We are exactly at time. I wish I could come back to Professor Banerjee also for a question. Unfortunately, I can't, but I will have to conclude, but I do want to just use one phrase each from each of the speakers to illustrate the range of interventions we've had. Dr. Karkoutkar talked to us about the need to understand continuous dynamics. Jacqueline then talked about the data need not be real time for us to learn. Amir talked about business continuity, how quickly we can bring societies and businesses back online. Olga referred to how we need to ask ourselves if it's accurate, real time, and are we prepared. Dr. Moraes talked about resilience of the people. But most importantly, I want to re-emphasize this point that Professor Banerjee made about systems acupuncture. If we don't keep testing and stress testing the pressure points in our overall infrastructure system, in a system dynamics way, we will struggle to deploy the innovations that we've heard from today. And if we did that, they would actually transform the way we engage with our infrastructure from resilience at one hand to criticality on the other. Thank you so much for your attention.